Hello students, so today we are going to start with exercise 1.2 from chapter number 1. So we have to express each number as a product of its prime factors in question number 1. So in the first one we have to write the prime factors of 140. So we'll prime factorize 140 and we'll start with 2 times 70, then again 2, then 35, then 7, then times 5, and then 5, then it is 1. So we can say that prime factors of 140 are 2 times 7 times 5. Now we will do second part. So the given number is 156. We have to find the prime factors of 156. We'll start with 2 times 7, then it will be 8, 78, then again we'll go with 2 times 3 is 6, 39, then we'll go with 3, 13, and 13 is a prime number, so we'll say 13 times 1 is 13. So prime factors of 156 are 2 times 3 times 13. Now we have to prime factorize 3825. We'll start with 2. We'll start with 5. As it has 5 at the ones place, it is divisible by 5, so it will be 7, then 6, then 5. Then again it's divisible by 5, then it's 1, then 3, and then 5, and then 3, and then we'll go with 3. It's 51. Then again 51 is divisible by 3. 3 times 1 is 3. Then 17 is a prime number, and then it's 1. So prime factors of 3825 are 5 times 3 times 17. Okay, so now we will do fourth part, and the given number is 5005. So we have to find prime factors of 5005. We'll start with 5. It will be 1, 0, 0, 1, and 1001 is divisible by 7. So it will be 7 times 1 is 7, then it will be 4, and then it will be 3. 143 is divisible by 11, then it's 11 times 1 is 11, and then 13. 13 is a prime number, so it's 1. So prime factors of 5005 are 5 times 7 times 11 times 13. Okay, so now we have to find the prime factors of 7429. Okay, this number is divisible by 17, and 17 is also a prime number, so we'll start with 17. It would be, then it's 437. Then 437 is divisible by 19. 19 is also a prime number, then it's 23, and 23 is itself a prime number, so it's 1. So prime factors of 7429 are 17 times 19 times 23. So now in question number 2, we have to find the LCM and HCF of the following pair of integers, and we have to also verify that LCM times HCF is a product of two numbers. So we know that if we have two numbers, let's suppose A and B, the product of A and B should always be equal to the product of their LCM. It is LCM of A and B and the HCF of A and B. We have to prove this thing also. So we'll start with the first part. In the first one, we will first find the LCM and HCF numbers of 26 and 91. Start with the prime factors. Start with 26. It's divisible by 2. Then it will be 13. 13 itself a prime number. Then 1. 91 is divisible by 7. We'll start with 7 times 1 is 7. 21. Then 13. 13 is a prime number, it's 1. So the prime factor of 26 are 2 times 13. 91, it is 7 times 13. Now to find the HCF, we have to make the pair of common prime factors. It has 13 as a common prime factor. So HCF of the given two numbers is 13. Now for the LCM, we need to make the factors same. So what we can do, let's take 91. So it's 7 times 13, and also we have to make the factors same, so it's multiplied with 2 and it with 7. Observe, both of them have same factor, same multiples now. These are multiples now, 13 times 2. So this is how we find the LCM. So it's 7 times 13 times 2. So if we multiply all these, we will get 7 times 2 is 14, and 14 times 13 is 182. So LCM is 182. Now we have to check also. We have to check that the product of the given two number, that is 26 times 91, should be equal to the product of the LCM and HCF. LCM is 182, HCF is 13, and 182 times 13 is 2366. And if we multiply these two, we will get the same number. It will also be equal to 2366. Hence they both are equal. Hence it is proved. Now we will do second part of the second question. Here the given numbers are 510 and 92. We have to first find the prime factors of these given two numbers. For 510, we'll start with 2. 2 times 2 is 4, then 5, then again 5. Then we'll go with 5. 2 times 5, then 1. 51 is divisible by 3. 3 times 1 is 3, then 7, then 17, and then it is 1. For 92, we'll start with 2. It will be 46. Then 2, it will be 23, and 23 is a prime number, so it will be 1. So the prime factors of 510 are 2 times 5 times 3 times 17, then 92 we have 2 times 23. For the HCF, we will make the pair. They both have 2, and okay, this is the only prime factor that is common. So HCF of the given two numbers is 2. For the LCM, let's take the prime factors of 510, that is 2 times 5 times 3 times 17. And then multiply it with the remaining factors of 90, that is 2 times 23. So LCM of the given two numbers is, if we multiply all these, we will get 23,460. Now we have to check that the product of the two numbers, that is 510 times 92, should be equal to their LCM times HCF. HCF is 2 and LCM is 23,460. If we multiply these two, we will get 46,920, and if we multiply these two numbers, we will also get the same answer, 46,920. Hence it is proved. Now we will do third part, and the given numbers are 336 and 54. First, we have to find the prime factors of these two numbers. Start with 336. We'll start with 3. it will be 1, 1, 2. Then we will go with 2, 56. 56 is divisible by 2, then 2, then 8, then it's 2, it's 14, and then 2, then it is 7. Okay, now for 54 we'll start with 2. 2 times 2 is 4, 1 4 is, then 7, then 3, then 9, then 3, then 3, then 3, then 1. So the prime factors of 336 are 3 times 1, 2, 3, 4. 2 times 2 times 2 times 2 times 7, and 54 we have 2 times 3 times 3 times 3. Now for the HCF, make the pair, these 3, this 2. It means we have 3 and 2 as a common prime factor. So HCF is 3 times 2. For the LCM, let's take the prime factor of 336, that is 3 times 2 times 2 times 2 times 2 times 7, and then multiply with the remaining prime factors of 54, that is these 2, times 3 times 3. So if we multiply all these, we will get 3024. Now we have to check that the product of these two numbers, that is 336 times 54, should be equal to product of the LCM. LCM is 6, sorry, HCF, that is 6. HCF times LCM is 3024. So it's equal to 18,144, and the product of the numbers will also be equal to 18,144. Hence it is proved. Now we will do question number 3. In question number 3, we have to find the LCM and HCF of the following integers by applying the prime factorization method. So we'll start with the first one. Find the prime factors of 12. Prime factors of 12 are 2 times 3. Of 15, prime factors are 5 times 3. 21, prime factors are 7 times 3. Now we will make the pair of the common prime factor, that is in all 3. 3 is the only prime factor that is a factor for all the numbers. So it means HCF is 3, and for LCM, take the prime factors of any number. Let's take of 12, that is 2 times 3, and multiply it with the remaining factors of the other two numbers, that is 5 times 7. So if we multiply all these, we will get 420. Now we have to find the LCM and HCF of the other 3 pair, that is 17, 23 and 29. So what do you observe in all these 3 numbers, 17, 23 and 29? Yes, these 3 numbers are itself a prime number. So if we prime factorize 17, we will get 17 times 1. 23 will be equal to 23 times 1. 29 will be equal to 29 times 1. Now if we make the pair of common factors, it's 1 only. So HCF is 1, and for the LCM, you just multiply all the 3 numbers, that is 17 times 23 times 29, and if you multiply all these, we will get 11,339. So it means if you have to find the LCM of prime numbers, just multiply the number itself, you will get the LCM. Now in third part, given numbers are 8, 9 and 25. Prime factors of 8 are 2 times 2 times 2. 9 we have 3 times 3. Let's write 1 also. 5 as 5 times 1. So to find the HCF, just make a pair of common factor, group the common factors. So here HCF is 1, and for LCM just multiply all these. So we will get 2 times 2 times 2 times 3 times 3 times 5 times 5, or at the end we can say it's 8 times 9 times 25, and it will be equal to 1800. So LCM of the given three numbers is 1800. Now we will do question number 4. In this question we are given with the HCF of two numbers and we have to find the LCM. So the given numbers are 306 and 657. Their HCF is given to us 9. We have to find, yes, we have to find the LCM of these two numbers. So we know the relation between two numbers, that if we have multiplying two numbers, that A and B are the two numbers, if we multiply them, their product should be equal to the product of their LCM and their HCF. Using this relation, we can see that 306 times 657 should be equal to LCM times HCF is given here, that is 9. So LCM will be equal to 306 times 657 divided by 9. If we simplify this, we will get 22,338. So LCM of the given two numbers is 22,338. Now we will do question number 5. In this question we have to check whether 6 raised to the power can end with the digit 0 for any natural number. So we have to check whether this number 6 raised to the power n can end with the digit 0 for any natural number. So we know that if any natural number, if any natural number ends with 0, then its prime factor include two raised to the power n times 5 raised to the power n. Let's understand this with the help of an example. Let's suppose we have to find the prime factors of 10. Prime factors of 10 are 2 and 5. Let's take any other number that ends with 0. Let's take 20. Prime factor of 20 are 2 times 5. It also has both the prime factors 2 and 5. It also includes 2 and 5. So if we prime factorize 6 raised to the power n, it will be equal to 2 times 3 raised to the power n. Or we can write it as 2 raised to the power n times 3 raised to the power n. It includes only 2 raised to the power n. It does not include 5. Prime factors of 6 raised to the power, it does not include 5 raised to the power n. Hence, 6 raised to the power n cannot end with digit 0 for any natural number. So now we will do question number 6. In question number 6, we have to explain why these two given numbers are composite numbers. So let's first do a recall or recap of the prime numbers and composite number. Prime numbers are numbers that have one or two factors. That is one and a number itself. Let's take the example 2, 3, 5, 7, 11. These have only two factors. Prime factors of 2 are 2 and 1. For 3 we have 3 and 1. Similarly for 5 we have 5 and 1. And composite numbers are the numbers that have more than two prime factors. For example, 4, 6, 9 and so on. Prime factors of 4 are 2. Factors of 4 are 2, 4 and 1. And factors of 4 are 2, 4 and 1. So it has more than 2 factors. Factors of 6 are 2, 3, 6 and 1. It has more than 2 factors. So a prime number, a number that has only 2 factors, 2 and the number 1 and the number itself. Composite number are those number that has more than 2 factors. Now we will do this question. In the first number, it's given that the given number is 7 times 11 times 13 plus 13. So the given number is 7 times 11 times 13 plus 13. So it has two parts, and both of them has 13 as a common factor. By using distributive property, we can take out 13 as a common factor. So it will be left with 7 times 11 plus 1. If we simplify this, 7 times 11 is 77 and 77 plus 1 78. So we can write given number as a product of two numbers. So it means it is a composite number. And for second part we have 7 times, 6 times, 5 times, 4 times, 3 times, 2 times, 1 plus 5. Again, by using property, if we see both of them has 5 as a common factor, so take out 5. So it will be 7 times, 6 times, 4 times, 3 times, 2 times, 1 plus 1. If we simplify this, we will get 5 times 1008 plus 1, which will be equal to 5000. 5 times 1009. So it is a composite number. Okay, so in this question it's given that there is a circular path around a sports field. As you can see, this is a circular path, and Sonia takes 18 minutes to drive one round. Let's suppose this is a starting point, and if Sonia starting from this point, she takes 18 minutes to drive one round, and while Ravi takes 12 minutes to cover one round. Suppose they both start at the same time, same point at the same time, and go in the same direction. After how many minutes will they meet again at the starting point? So it means it's given that Sonia, she takes 18 minutes, and while Ravi takes 12 minutes. So it means Sonia can cover one round in 18 minutes. She can cover two rounds in how many minutes? You will do 18 plus 18, that is 36. And similarly, you can go on. And for Ravi, he completes one round in 12 minutes, two round in 24 minutes, right? And now we have to find out after how many minutes will they meet again. So if they are starting from this point, starting point at the same time, and after how many minutes they will meet again. So it means we have to find the LCM of these two numbers. That is, we have to find LCM of 18 and 12. To find the LCM, we need to find the prime factors of 18 and 12. Prime factors of 18 are 2 times 2 is 2 times 3 is 6, and 6 times 3 is 18, and for 12 it is 2 times 2 is 4, and 4 times 3 is 12. Now just make the common pairs. These are the common pairs 2 and 3. For LCM, first write down the common pairs and then write down remaining prime factor, that is 3 and 2. So 2 times 3 is 6 and that is 6, that is 36. So LCM of these two numbers is 36. It means they will meet again at the starting point after 36 minutes. Hope this video was helpful to you. Thank you, and don't forget to like and share.